Look at your hand. What do you see? Look closer. What if I told you you're looking at 10 million atoms? That's 10 with 25 zeros after it. In fact, everything from the chair you sit on to the air you breathe is made up of atoms. And there are so many of them that it's impossible to count in one lifetime. And yet, researchers can make computer chips so small, they're made with only a few hundred atoms. So small that we can't use regular microscopes to see them. So how can we see an atom? And how do we do studies at the atomic level? Well, my research uses a special microscope called the scanning tunneling microscope. And although this is going to sound sci-fi, it uses a phenomenon known as quantum tunneling. Now, quantum tunneling is fairly simple. Quantum essentially just means really small, and tunneling just means to tunnel. Let's say I have a boulder, and I need to get this boulder from one side of a mountain to the other. I'm no Sisyphus, and I couldn't even start climbing a mountain, let alone push a boulder over it. But if I take that boulder and I shrink it down so much that it becomes quantum, the boulder itself can pass through the mountain to the other side, as if it's going through an invisible tunnel. And if I make that mountain smaller, the boulder has an easier chance of tunneling through the mountain. And that's quantum mechanics. And it turns out that electrical current, something that we use every day to charge our phones, are made up of these tiny, tiny quantum boulders. And instead of trying to tunnel through a mountain, electrical current can tunnel through the air. So if I take a really sharp piece of electrical wire and bring it so close to a surface I'm interested in, without them touching, electrical current can go from that wire through the air to the sample. And if I hold that height and I start to scan in a direction, if there's an atom there, the distance between the tip and the sample becomes smaller, or my mountain becomes thinner, and I get more electrical current. So I can do this for a whole area, keeping track of the change of electrical current as I go, and I can generate a three-dimensional map of the atomic surface. Not only that, since I'm already using electrical current to take my image, I can use it to measure the electronic properties of the material at the same time, atom by atom. So not only do I generate really cool images like the silicon behind me, but I look at emerging technologies that are coming out every day. Technologies like nanowires that are made of tens of atoms but have huge implications in clean water and green energy solutions. Things like those computer chips from before, where I can take a single atom and pluck it out or move it around and see how that changes the electronic properties of the chip. Even things like superconductors, where fundamentally understanding how they work can allow us to solve problems like electrical transport. My research serves to understand how things work at the atomic scale, so I can get them to work at our scale. And I can do it with a simple picture. Thank you.